Today we're going to talk about solution sets and intersecting graphs. A solution in math is a number, or sometimes a point, that makes an equation true. Remember to write down definitions as you go through the videos. So when I graph an equation, what I'm actually doing is graphing all the points or numbers that are solutions to that equation. Some equations have only one solution, like an equation in one variable, like 2x minus 1 equals 9. When I go through and solve that equation first by adding 1, then by dividing 2, I get one number of 5 that is a solution. I can test that solution by plugging the number back into my equation. Since x was equal to 5, I'm going to replace x with 5. When I multiply 2 times 5 and subtract the 1, I find that both sides of my equation give me the same value. That means that 5 is a solution. Using that same method, I can tell that a point is a solution to an equation in two variables by plugging that point into the equation for x and y to check to see if my equation makes the statement true. For instance, I have an equation 2x plus y equals 7. I want to find out if the point 4, 0 is a solution to that equation. Remember, in a point, the first value is x, the second value is y. So 4 is my x value, 0 is my y value. That means I'm going to plug 4 in for x and 0 in for y. When I multiply the 2 times 4 and add the 0, I find out that my two sides do not give me the same value. That means that the point 4, 0 is not a solution to this equation. I'm going to check now to see if the point 4, negative 1 is a solution to that equation. I'm going to put 4 in for x, negative 1 in for y. When I multiply the 2 times 4 and add the negative 1, I find that both sides are equal. That's true. So 4, negative 1 is definitely a solution to this equation. I'm just looking for points that make that equation true. This equation actually is going to have a lot of solutions, an infinite number of solutions to be exact. So to show all of those solutions would literally take me forever to accomplish. I can draw a graph of this equation and kind of shortcut the process and show all of the solutions instead of trying to list them one by one. So here's the graph of our equation 2x plus y equals 7. Remember that we just tested the point 4, negative 1 and found that it was a solution. That means that the point 4, negative 1 is on that line. We tested just before that to see if the point 4, 0 was on that line. And that was not true, right? So 4, 0 is not a solution because it's not a point on my graph. I can pick any point along that line, and if I plug that into my equation, I'll find that it makes a true statement. So what happens when there's more than one graph on a page? In other words, a system of equations. Last year, you looked at systems of linear equations, where you graphed two lines and found the point where they meet. That point where they meet was the solution to both equations. This is a point where if I plug that x value and y value into both equations, both of them should give me a true statement. When there's nonlinear graphs involved, there can be more than one solution that fits both equations. In this graph, I've graphed y equals x squared and y equals negative x plus 2. There's 2 points where those lines meet instead of just one like with our linear graphs. So that means negative 2, 4 and 1, 1 are both solutions to both equations. If I plug those values in one by one, I can plug negative 2, 4 into both equations, and I can plug 1, 1 into both equations, and all 4 equations should come out as true statements. So what can I use this for? I can use this for choosing a cell phone plan, the right investment for me, the right loan for me to maybe buy a house or a car. There are a lot of things that you can use this process for in your life. For instance, here's a graph that shows Brian and Andrew's height as they age. I can look at this graph and say, what age are they when they're the same height? The point where they meet. There's only one point where the two graphs meet, and it's right there. That means that when they were both 15 years old, right? Or I should say when Brian was 15 years old, they were both just over 5 feet tall. When they were younger than 15 years old, who was the taller sibling? Well, to the left of when Brian was 15 years old, right? Brian was the taller of the two. And after they were 15 years old, Andrew started catching up, and Andrew actually was a little taller than Brian. The point where they intersect was about 15 and 5.3, let's say. What is that point trying to tell us about Andrew and Brian? Well, it actually says that when Brian was 15 years old, they were both about, let's say 5.3 feet tall. Let's look at one more example. Jacob and Antonio are incoming high school freshmen with big plans for a trip to Europe after they graduate in 4 years. They need to save $3,500 for their trip. Jacob has a job, and he's going to put $150 in his savings account each month. Antonio sold his baseball card collection for about $4,500 and is going to be careful to spend only 2% of his money each month. Let's look at the graphs of both equations and answer the questions to come. Here's the graph of both equations. Let's take a closer look. So Antonio, he does not have a straight line. His equation is not linear, right? Because he started with $4,500 and he is losing 2% a month. That's an exponential function. Jacob, on the other hand, started with 0 and is adding the same amount of money every month to his account. So his is a linear line. The x-axis is the number of months. The y-axis is their amount in dollars that they have. So question number 1 says, who will have more money in a year? In 1 year, how many months is that? 1 year is 12 months. So after 12 months, who has more money, Jacob or Antonio? Well, it looks like Antonio has more money at that point. So let's put that answer down. Let's say Let me get a better pencil point here. Antonio. After 2 years, who will have more money? After 2 years, that's 24 months. It looks like now Jacob is taking the lead, and Jacob will have more money. Question number 3 says, will the boys have enough money for their trip in 4 years from now? Well, 4 years from now is 48 months. It looks like Antonio is only going to have, probably between $1,600 and $1,800. Is that enough money for his trip? I don't think so. Jacob, on the other hand, is going to have much, much more than $5,000 if this line is any indication. So will the boys have enough money in 4 years? For Jacob, the answer is yes. But unfortunately for Antonio, the answer is going to be a big no. The next question asks, what's the solution to the 2 graphs? Remember, the solution when I have 2 graphs to a page is the point where they meet. So this point is at an x value of 20 and a y value of 3,000. That's my solution. And finally, what is the solution trying to tell us about the 2 boys? Well, what it's saying is 20 is the number of months, right? 3,000 is the number of dollars. It says after 20 months, both boys have $3,000. Sorry, the pen isn't working very well, but hopefully the message will get across anyway. See you in class next time we meet. Remember to rewind the video and look at examples that you need refreshers on, and make sure that you're writing down definitions and examples. Have a great day and good luck.